All right, guys, we're going to do lesson 11.5 today. Welcome to the last week of algebra, by the way. We only have 4 more lessons to go counting this one. We're not going to have any math on Friday. In fact, Friday will just be kind of a fun day where we get together on Zoom and kind of close things out and give awards to everybody and things like that, okay? So we're almost to the end. Don't give up now. We're so close to being done. Keep up that effort till the very end, okay? I'm learning a couple more things yet this year that'll come in handy for you guys in high school and beyond. Today we're going to be dividing polynomials. And we're going to divide polynomials by monomials, one piece things. We're going to divide polynomials by binomials. And then we're going to also divide using what's called long division. And so there's a couple different ways they're going to show you how to solve these problems, and they're going to want you to use that second way a few times today. All right, when you're dividing polynomials by a single piece monomial, notice single piece, what you're going to do is you're going to split it up like this, and divide each of the pieces by the monomial, okay? And then that allows you to cancel a lot of things out. Notice on this one, we can cancel out an x and a 2. So that all that leaves is just plain old x here, right? And when we divide these out, we end up with 8 on the top. This cancels out, right? And our x's cancel out. So all that's left is 1 on the bottom and x plus 8 on top. And so in other words, our final answer is just x plus 8. Here would be one more example of that, right? This one's got 3 pieces, so we're going to write them all separately, spread out a little bit, and we're going to divide them all by that monomial, that one chunk piece. Okay, first piece, notice we can cancel out a b, so this just becomes b to the first, right? Second piece, we can divide them both by 3, that would give us 4 and 1, and then this these b's would cancel out, right? And then on this last piece, we can't divide anything out at all. So let's just write what we've got, what's left. On this first piece, we have b over 3 plus 4, and then minus 14 over 3b is our final answer. So those are pretty quick and easy, I think you'll find. Then they're going to teach you how to divide polynomials by binomials. So when you got a 2-piece that you're dividing by a binomial, right, one that's got two numbers separated by a plus or minus sign, what you're going to want to do is stack them up, but factor them, okay? So let's factor this first piece. We can definitely do that, right? So let's think, what would that factor to? How about h plus 3 and h plus 6, right? And then we're dividing that by h plus 6. See how that works? And then we can just cancel out. Cancel out, cancel out. So our final answer is just all that's left is h plus 3. So here's another example of dividing by a binomial. Okay, let's restack it. We'll factor as we do. We can do b minus 5 and b plus 3, right? That would give us the minus 15, which add up to negative 2. And then we're going to divide by b plus 3. Notice the canceling out. Notice the final answer. That's all that's left. Okay, those I think are pretty quick and easy as well. Okay, they're going to insist that you use another method to solve some of the problems today. They're going to insist that you use long division. Here's why. There are some problems that are going to show up today where long division is going to be the best way to solve them, okay? So on this next problem, you could have solved this next one just like we did the previous 2 by factoring and then dividing. But they're using these to teach you a skill that will come in handy later in the lesson, okay? So I am going to insist, if it does say to use long division, which it does for a few of our problems today, make sure you do use the long division method. I'll be looking for that in your work just so that you know how to do this, okay? Even if you can solve it a different way. So we're going to write this just like we would a division problem with 2 whole numbers. We're going to put the first number under the division box, the second number outside the division box. Now, if you think of it this way, I think this makes the most sense. We want the y's to disappear. So what we're going to do is we're just going to consider this y and this y right here, okay? How can I change a y into y squared? What would I multiply it times to make y squared? Wouldn't I multiply it times y? Okay, and so I'm going to put a y there because that's what would change this into that, right? And now I'm going to multiply that y times this whole thing, just like you would if you were doing long division with whole numbers. So I get y squared, which is going to make that y squared disappear, plus 3y. See how I got that? Okay. And then we can subtract, just like we do with normal long division. We end up with those y squareds being gone. Cool, that's what I wanted. And I have 1y, and I bring down my 12, okay? Then once again, I'm going to ask myself, how can I change this y, just this first number, into this y here? Wouldn't I take it times 1? I would, right? And so I'm going to put plus 1 on top here, And I'm going to take 1 times that. So I'm going to end up with y plus 3. Okay? And notice I canceled out those first y's. They're gone. And then I have 12 take away 3, right? So I have 9. And that 9 is actually our remainder. And so the way we write that is we say y plus 1 was our answer, and then 9, we write our remainder like as a fraction like we did sometimes when we were doing mixed numbers division, right? 9 over y plus 3. And put a plus sign right between those things right here. There we go. So there's our final answer. I know that's a lot to take in. We're going to do at least one more together like that and then one near assignment like that to help that sink in. But your goal each time is to make the variables disappear. If you think of it that way, I think that makes some sense. Okay, here we go. We're going to use long division again. So I'm going to put this first one in the box, and I'm going to put this one outside. Okay. Now remember, I'm just going to compare my variables. Okay. I want to change that x into 3x squared. How am I going to pull that off? Wouldn't I take it times 3x? I would. So I'm going to write 3x right over the top of this, and then I'm going to multiply that times this side piece. So I get 3x squared, cool, that's just what I wanted, plus 15x. And then I subtract these like I normally would, right? These cancel out, sweet, that's what we wanted. 9 take away 15, though, gives me negative 6x minus 15. Okay, so again, I want the x's to disappear, so I'm going to just consider this x, and I'm going to look at this piece right here. What would I take that x times to get negative 6x? Wouldn't I take it times negative 6? I would. So I'm going to put a minus 6 up here, and then let's take that times this whole side piece. Negative 6x minus 30. Okay, so now I subtract these. Okay, minus 6x minus minus 6, right? So in other words, plus 6 would make these cancel out. And then negative 15 minus minus 30, so in other words, plus 30, leaves us with positive 15 left over, right? And so that's our remainder this time. And so we're going to put that over this number here, plus 15 over x plus 5. Now be careful, as you saw, you have to think like minus minus 6 and minus minus 30. In other words, plus 6 and plus 30. Be careful when you do those problems, okay? Okay, they're going to give you some tricky ones where you have some terms missing. Do you see how this first term is to the third power? And then we go right to c to the first power. We're missing a term. We should have c to the second power here. So when a term is missing, here's what you need to do. When you write it under a division box, because they're going to want you to use long division for these missing term ones, okay? You're going to write it with that missing term in there. So you're going to say plus 0 c squared plus 5c minus 6. Important to do that because that's going to give you the right answer on top, right? And we're going to divide that all by c minus 1. Okay, then just like we did before, we're going to consider only this and ask ourselves, how do we turn it into that, okay? All right, so we're going to take that times c squared, aren't we? So I'm going to put that right here. And I'm going to take c squared times everything. So c squared times c gives me c to the third. Good, I want that to cancel out. And then minus c squared, right? Minus 1c squared, I guess you could say. So we do our subtraction. So when we do our subtraction, these are going to cancel out. We get nothing here, right? Nothing here. And then notice, careful, this next one is, it's 0c squared minus 1c squared, so plus. So in other words, we get positive c squared. Okay, let's pull down our next piece, okay? And let's ask ourselves that same question. How can I change this c into c squared, right? Wouldn't I add c? And so now I'm going to multiply. C times c is c squared, and c times negative 1 is negative 1c. Okay, so I subtract. That first piece cancels out, right? And then careful, this is 5c minus minus 1c. So we end up with 6c, right? So plus 1c minus 6. Okay, we have one more piece to do. So how can I change this c into 6c? By adding 6, right? And so that gives me 6c minus 6. And notice this one's not going to have any remainder at all, because when I subtract, these pieces cancel out, right? 6c take away 6c, and then negative 6 minus minus 6, in other words, plus 6 gives me 0. So this one doesn't have a remainder whatsoever. There's our final answer. Okay, here's one more example of those, because those are a little tricky, okay? I'm going to rewrite this under a division box. Notice this one has a missing term. It has 2r to the third, 2r to the second, but there's nothing to the r. So I'm going to put 0 to the r minus 4. Okay, and I'm going to put r minus 1 out here. Okay, I'm going to ask myself, how can I change this r into r to the third, right? And wouldn't I take it times r squared? I would. So I'm going to put that right here over the other r squared below the box. So I multiply these together. And sorry, I'm realizing I need a 2 here too because I want to change it into 2r to the third, right? So I multiply these together and I get 2r to the third, okay, minus 2r squared. So I subtract these. And notice what I get. These pieces cancel out. That's exactly what we want. And careful, we have minus 2r squared. So in other words, plus 2r squared. So we get 4r squared. Okay, I'm going to pull in my 0r here. Okay, and then we're going to ask ourselves, how can I change this r into 4r squared? Wouldn't I add 4r, right? So now I'm going to multiply that times that side piece here. So 4r times r is 4r squared. Cool. That's what we wanted. And then 4r times negative 1 is minus 4r. Okay, these cancel out. That's exactly what we want. Careful, this is 0r minus 4r. So in other words, plus 4r. So we get 4r. And we'll bring down our negative 4 here. So we have 4r minus 4. Okay, so how do I change r into 4r? Well, wouldn't I take it plus 4, right? 4 times r is 4r, and then 4 times negative 1 is minus 4. So notice these cancel out, cool. And then this becomes plus, right? Negative 4 minus 4 would be negative 4 plus 4, in other words, 0. So once again, we don't have any remainder whatsoever. Okay, so that's why you do need to use long division for certain problems, because there's remainders sometimes, or you have a missing piece, and so you can't go about solving it the easy way we showed you at the beginning for those first two types of problems. Okay, let's do a few of your assignment problems. I know this is probably more of a challenging lesson. Maybe you're picking it up pretty quickly, but I know it's something brand new, so let's do a few together just to get you off to a good start today. Notice we're dividing by a monomial, so we can do this the easy way, just like we did those first examples. We can just stack them up like this, and then divide both of the pieces by that 4a, right? So on this first piece, we can divide them both by 4, which would make this a 2, and then we can divide them both by a. So this ends up just being 2 over 1, right? Plus, and then notice both of these we can divide by 4, and then our a's disappear. So 2 over 1 plus 5. Sorry, 2a over 1 plus 5. I forgot about this a, my apologies. And that's our final answer, 2a plus 5. Let's do number 7. Number 7 is a word problem. It's still a division problem. Notice it says the number of beakers that can be filled with 50 plus x millimeters of solution is given by 400 plus 3x divided by 50 plus x. So really it's just a division problem, right? We have 400 plus 3x divided by, divided by 50 plus x. All right. So what I'm going to do is I'm just going to rewrite this piece as x plus 50, right? Would mean the same thing. Okay, and then let's divide. We're going to use long division for this one. Divided by x plus 50. All right, then let's do some long division to solve. Tell you what I'm going to want to do first is flip-flop these numbers. We want the x's to be first, like when we were doing long division. So let's flip-flop these numbers too. My apologies for that. Let's put 3x plus 400. There we go. Now we've got our x's first on both, so they match. All right, here we go. Let's do our long division. So how can I change x into 3x? Wouldn't I multiply it times 3, right? So that gives me, if I multiply 3 times this whole thing, I get 3x plus 150. Okay, now I'm going to subtract like we do in normal long division. These disappear, sweet. And over here we're left with 250. And so notice that's our remainder, isn't it? So our final answer is 3 plus 250 over x plus 50. So there you go. That's how many can be filled. Really kind of a strange answer, but that is correct. Notice on number 8, it does say use long division for this section, okay? So I think there's just, 4 there that you're going to need to use long division for, okay? So do follow those instructions. It won't work to use the other method. You could try it. It's not going to work because if you can't factor this, there's no way to do that, right? You could think 5 and 2, but that wouldn't give you 3. And so we have to use long division to solve this one. So we're going to do that. N squared plus 3n plus 10. That's why they had you learn long division, because there are definitely problems like these that you can only solve using this method, okay? Now remember, your method of solving these is to think, okay, how can I change that into this? Because we want to make the n's slowly disappear, right? So we're going to take it times n, aren't we? So I'm going to put that over the other n underneath my division box, and let's multiply. N times n gives us n squared, cool. And then n times negative 1 gives us minus, 1n, right? And so now if we subtract, okay, this cancels out. That's exactly what we want. And then 3 minus 1n gives us 4n. And I'll bring down my plus 10. Okay? Now, again, I want to change my n into 4n. How would I do that? Wouldn't I take it times 4? I certainly would. 4 times n gives us 4n. 4 times negative 1, minus 4. Okay? So these cancel out. 10 minus 4, so plus 4. And there's our remainder. So on this one, we put the remainder at the end over the top of our divisor, n minus 1, just like you do if you were writing a mixed number after dividing, okay? So that's one example of one of the long division ones for you. Now what you have to be careful of in numbers 8 to 11 is, I believe there are 2 like this. Yes, number 10 as well. Be careful. There are some problems that are missing a term. This one is missing a term. Do you see that? There is nothing n to the second. So remember, when there's nothing, you got to put a 0 there. So this is still in that long division section. So we're going to write it like this. Notice we have nothing n to the second. So we're going to put 0 n to the second minus 13n plus 8, right? Don't forget to add those missing terms. Number 10, I'm going to put that up here. Don't forget. You also have a missing term, okay? Don't forget to do that same thing. And then 3n minus 1, okay? All right, now we're going to do long division again. We're going to ask ourselves, how can I change that into this? Wouldn't I take it times 3n squared, right? So I'm going to put that above the n squared below the division box right here. And then let's multiply this that we just wrote times this whole thing. So 3n squared times 3n gives us 9n to the third. Perfect. And then 3n times negative 1 gives us 3n squared minus, okay? We subtract, these cancel out. That's exactly what we want. And we have 0n squared minus 3n squared, so plus 3n squared, okay? Let's bring down our next number. And once again, we're going to ask ourselves, how can I change this 3n into this 3n squared? Wouldn't I just add 1, right? When I just multiply it times 1n, I should say. There we go. So we get 3n squared. So that gives us 1n times 3n gives us 3n squared. And then 1n minus 1 gives us minus 1n, right? So we take it away. These cancel each other out. Remember, minus 1n would be plus, right? So negative 13n plus 1 gives us negative 12n here, right? So now we bring down our last 8. Okay, once again, how can I change this 3n into negative 12, right? So I'm thinking, oh, I got to take it times, or negative 4, don't I? So I'm just going to get rid of these lines here. Let's do that. Let's take it times minus 4. So that gives us minus 12n, right? And then negative 4 times negative 1 is plus 4. So I subtract these, right, just like we do in long division. Minus minus makes a plus, right? So this cancels out, sweet. And then minus 8 minus positive 4, so minus 4, in other words, leaves us with 4 as our remainder. So let's write our remainder like this at the end. We put 4 over our divisor, 3n minus 1. And there's our final answer, 3n squared plus 1n minus 4, plus our remainder 4 over 3n minus 1. Hopefully that's making some sense. I know these long division problems take a little while to get a hang of. I'd be more than happy to do a few of these with you on Zoom if you want to talk these through some more. But hopefully after seeing me do about 5, 6 of those problems in both the lesson and some of these examples right out of your assignment, that it's starting to click. Don't be afraid to reach out, though, guys. Have a good Monday. Last Monday of the year. How cool is that? In fact, last Monday for most of you other than Eli, last Monday of grade school. How cool is that? Have a good day, guys.